Hello, hello. This video will be going over our Unit 4 mid-unit quiz. So there are two main types of questions that you're going to see on your quiz, those being finding solutions for equations and finding solutions for systems of equations. So I want to prepare you guys, give you guys a couple examples for you guys to study and prepare for yourselves over the weekend. So let's get started. We are first going to look at our 4.1.1 worksheet 2. So this is the section where we went over how to solve equations using our operations chart and inverse operation chart. And the whole idea is that you're supposed to use this chart in order to figure out how you are going to cancel the operations around x. Because in order to solve for x, means that your answer should look like this. Your x should be equal to some value. So that means you need to get x by itself. You need to eliminate everything that is around x. And the way that we do that is by first understanding and listing out what happened to x. So looking at number one, I'm going to go ahead and make my operation table and my inverse operation table. And how I'm filling out this table is what happened to x in order. So looking at my equation here, first I identify my x, I found them, and now I need to figure out what affected x first. And you'll notice that x is inside parentheses, meaning that whatever's inside the parentheses with x got grouped with x, meaning that is directly affecting x first before anything else outside that parentheses. So that means my first operation that happened to my x is I got subtracted by 4. I did minus 4. So in the past, we would write out the word minus 4, but by this time, we've seen enough examples that we could start introducing shorthand. So that means that for my first operation, I'm going to write that we did minus 4 to x, and that was our first thing that happened. Okay? And from there, that is everything that happened inside my parentheses. So now that I've addressed everything inside, I can now start looking outside. And now you could say that my 3 and my 7 are both affecting my parentheses. One is being multiplied, the 3 in front, whenever a number is next to a parentheses, that means multiplication. And also the 7 is getting added, but they're both affecting my parentheses sort of at the same time. They're both directly outside my parentheses. So the way that I determine what goes next is by looking at my order of operations. Whenever you are looking at something that is affecting x at the same time, you go back to order of operations, that being PEMDAS. And I go down the order. What comes first, multiplication or addition? So that's parentheses, exponent. Multiplication comes before addition. So that means the next operation I'm going to say affects my x is times 3, and finally plus 7. And when I think I'm done, I'm going to go ahead and try and go through my list and make sure that all my operations are checked off. So I've done my minus 4, my times 3, and 7. And those are indeed all the operations that are affecting my x. There's nothing else that I need to cancel around my x. So now that I know that I'm done listing out my operations, now I need to figure out, okay, that's what happened to x. How do I undo each of these? And that's where our inverse operations come from or come into play. Because in math, I can't just get rid of things. I need to cancel them. And in order to cancel, I need to do the opposite operations. Opposites in math cancel one another. So if I have a plus 7, the way I get rid of plus 7 is by subtracting 7. The way I get rid of multiplication, multiplying by 3, is dividing by 3. And the opposite of subtracting by 4 is adding by 4. And by doing these operations in order, I will be able to cancel everything around x and get x by itself. Of course, inverse operations are opposite. We want to think inverse opposite operations. That means that we're going to start from the bottom and go up. So we list and start our inverse operations from the bottom so that we could cancel our operations in reverse order. And as we go through the math, you'll see that makes sense Because if I try to cancel my first operation first, if I try to do +4 to cancel this -4, I can't, because my x and 4 is inside the parentheses, and I can't affect what's inside the parentheses while there's still everything else around it. So if you come into a barrier like that, go back and make sure that we're doing the inverse operations in reverse order, starting from the bottom of your list and you're going back up. So what that means is that we're going to do -7 first. And of course, that is going to cancel. So +7, -7, cancel. That's the whole point of us doing this inverse operations, so that we could cancel. But of course, because of our rules of math, what I do to one side of the equation, I must do to the other. So that's going to be -7 to my right-hand side. So I'm left with 3. X minus 4 is equal to 10 minus 7 gives me 3. And I'm going to keep going down the line. My second inverse operation is going to be divide by 3, and that's going to be x minus 4. And at this point, I have nothing outside my parentheses, so I could actually get rid of them. And that's going to be equal to 1. Finally, I want to get rid of my -4 by doing, getting ahead of myself. The way I get rid of -4 is by doing +4. These are going to cancel, much like these canceled up here. And I am left with x by itself. And on the other side, I have 1 plus 4, which will give me 5. And that is how we start and complete these kinds of problems. Okay, so let's go ahead and get another example. Let's see what's another good one. I'll do two more for us, and I'll kind of, maybe I'll do three. We'll see. So the next thing I want to look at is something like number 4. This is another type of question that we've encountered. And the main hallmark of this one, the main thing that should stand out, is that this one has fractions. Specifically, it has two fractions, one having a denominator 4 and one having a denominator of 2. Now, we've said that we don't like dealing with fractions. If you don't cancel them very early on, then you're going to have to remember and deal with all the rules that come with adding, subtracting, multiplying, dividing fraction. So my advice and the strategy that we learned is to get rid of our fractions in the first step, or as early as possible. So the way that we do that is by reminding ourselves what fractions means. Because when I have a fraction, that means that we are dividing. So the way that we read this is x minus 2 is being divided by 4. So if we keep that in mind and we remember our operations and inverse operation, then I know that the way to cancel division is through using multiplication. So I'm looking at all my denominators, because what I do to one side, I'm doing to the other. So what I'm trying to find is a number that will cancel both with 4 and with 2 at the same time. And in this case, that number is actually right in front of us. That's going to be 4. 4 cancels with 2. 4 cancels with 4. And 4 also cancels with 2. Now, I'm using 4 because this will get rid of all my denominators. If I use something smaller than 4, then it wouldn't work. Let's say that I tried 2. So that would be 2 over 4 and 2 over 2. So 2 and 2 would cancel. That would equal to 1. 2 and 4 would also cancel, but what would be left with is 1 over 2. So if I use a smaller number than the denominators that I have, then I'm still going to be left with some denominator left in my function, left in my equation. And the whole point of me multiplying is for me to get rid of these denominators. So make sure you multiply by a big enough number where all your denominators are canceled by your second step. So if that's the case, then I'm going to go ahead and multiply this out. And remember, I can't just multiply to the fraction. I can't multiply to just the parts that I want. I must multiply to the whole equation, the whole side in its entirety. So my next step is going to look like 4 times x minus 2 over 4 plus 6 times 4 is equal to 7 times 4 over 2. And the reason I do this is to check and make sure that I'm multiplying 4 by everything. I'm multiplying by 4 in my first term, second term, and third term. If you just do it in your head, then it's very easy to forget to multiply to all the parts that you need to. So I very much recommend that you guys keep this step in your work. That being said, I am going to start to cancel because 4 divided by 4 gives me 1. They cancel each other out. And that's going to be x minus 2 is what I'm going to be left with. I'm going to just go and split this because I don't want my work to overlap with itself. And now I look at my next part. There is no fraction to cancel here. So this just becomes straight multiplication. That's going to be 6 times 4. So that's going to be plus 24. And when you have just numbers, when you don't have any parentheses or variables, you can still cancel because I'm going to do 4 divided by 2 gives me 2. But it might just be simple for you guys to just multiply this out and then simplify. 7 times 4 gives me 28. 28 over 2. Remember, fraction means division. So 28 divided by 2 is going to give me 14. And now I have successfully gotten rid of all of my fractions. And now this is much easier to work with than my initial equation here because I got rid of all my fractions. They're equivalent because I follow the rules of canceling and the rules of mathematics, but I manipulated in such a way that now it's now easier to work with. So with that being said, now I just follow my inverse operations. I want to get rid of my 24 first. I minus 24, minus 24, and that's going to give me x minus 2 is equal to negative 10. I add 2, I add 2. That is going to give me x is equal to negative 8. And that is my final answer. Okay? Now, you could have used your inverse chart here. What that inverse chart would have looked like is for your operations and for your inverse. Once we cancel all the fractions, we're going to start taking it from here. That would be what happened to x is minus 2 and plus 24. So what I did is minus 24 and plus 2. So if you need the chart, by all means. But for shorter equations, especially once we cancel our fractions, it becomes a little bit more simplified and easier to work with. You can just go through it. But if you're ever unsure or get something wrong, you should go back and rely on your chart to check your work. And I think I'll just model one more. So we'll model number 8, just because I want to make sure we're comfortable with the different kinds of operations that you might see. So looking at number 8, I'm gonna go ahead and make my chart over here just for the sake of space. I'm gonna make my inverse operations. Start with operations. I'm gonna have my operation charts, and of course have my inverse operations. And I'm looking about what happened to my x value first. So much like a parentheses, our square root also creates a group out of what is underneath it. So since x is in under my radical, I need to account for everything that happened under that square root before I deal with anything outside of that square root. So I notice that directly next to my x is my 2. So that's going to be times 2 is my first operation that happened to x. Next thing is going to be that plus 6. And now that's everything that's under my square root. From there, I can't deal with anything outside of my square root until I deal with the square roots itself. The square root is an operation. So you could write out square root, you could write a radical, just so long as you indicate in your list that that's the next thing that you need to deal with. From there, all we have is a times 2. And from there, we could go ahead and list out my inverse operations. I will number my operations in the order that they happen to remind myself to list my inverse operations in the reverse order. Remember, your inverse operations, whatever you cancel, is going to start from the bottom. That means I'm going to start with a divide by 2. Division is the opposite multiplication. The opposite of a square root is taking something to the power of 2. Opposite of plus 6 is minus 6. And of course, we divide by 2 once more at the end. In practice, what that looks like is I'm dividing by 2 by the whole side. I'm going to cancel my 2's. And what I'm left with is square roots of 2x plus 6 is equal to 4. 8 divided by 2 is 4. Next, I do my square root and squared. Now, I want to highlight this part right here because I want to remind ourselves that on our left-hand side, the side with my x value, I'm not doing any calculations. I'm not showing any work. Oh, you should be showing your work. Excuse me. I'm not changing this side. I'm not expanding it. I'm not adding new components to it. I'm not calculating this side. The whole reason I made my inverse operations list is so that I know how to cancel. So all I'm doing on the left-hand side is canceling. So you're not going to actually square out this whole side and write it as a parentheses and then multiply it out. All you're doing is recognizing that a square root and a power 2 are opposites, so they are going to cancel, meaning that I'm left with 2x plus 6. If you find yourself adding components or changing this side, then double check yourself and come back to the step before. And just remember, all you're doing on the left-hand side, the side with the x value, is canceling. Where you're doing the calculations, it's going to be on the right-hand side where we have the solution. So I need to remember what 4 squared is. That's going to be 16. And we're going to have minus 6 minus 6. I'm going to have 2x is equal to 10. Divide by 2, divide by 2, and I have x is equal to 5. And that's our answer for that one. And last thing I want to highlight on this specific worksheet is number 3. Only reason being is that I want to make sure that I cover the operations that you guys are going to see. So I have x minus 3 squared equals 16. We make our chart. And I see the first thing that happens to my x is going to be minus 3. And the next thing that happens is my power 2. Now, we should be fairly familiar with our other operations. Multiplication is the opposite of division. Subtraction is the opposite of addition. What new operations we're dealing with that we haven't had as much time to work with is that powers are the opposites of roots. So I have something to the power of 2. The opposite of that is going to be a square root. And we saw that in our last example. I want to make sure that you understand that it goes both ways. If I have a power 2, the way I get rid of that and cancel that is by doing a radical. And of course, we end out with a plus 3. But also, you need to be careful about what that looks like. So if we're going to cancel this, I'm going to do square root, square root. Again, I am not doing any calculations on this side. All I'm doing is canceling my square root and square, my power 2, and I have x minus 3 is equal to square root of 16. This is where you guys need to be careful, because whenever I take a square root value, I need to account for both its positive and negative solution, our positive and negative values, because 4 squared is equal to 16 and negative 4 squared is equal to 16. So because there are two solution options, when I'm solving for x to find my solutions, I need to account for both of those. So that's why I have this plus minus 4. But the other steps should just be like normal. My plus 3 and plus 3, and x is going to be equal to plus or minus 4 plus, plus 3. Now, if you just left this answer, this would be correct, but in algebra, we would like to simplify things as much as possible. So because we have a plus and minus value here, a positive and negative value, we're going to split that to show what those answers both would be. So I have 4 plus 3, I have negative 4 plus 3. So my two solutions are 7 and negative 1, and those are my two answers for number 3. From there, we have some easier problems and more complex problems. Number 9 and 10 are definitely the more advanced versions of these questions. But I will upload the answer key along with this video. So please try your hand at the rest of this worksheet so that you can get your own practice in. Okay? The only other type of question that's not represented on here that I do want you to be aware of is how to deal with absolute value. Now, we've done these kind of examples on our warm-up. There are plenty of them in the notes if you look back and see the slides that are also posted on Google Classroom. But I did want to at least model one of them for you here. So let's go back to one of our earlier warm-ups. And of course, I'm trying to find the solutions. So that means my answer needs to look like x equals something. I'm trying to get x by itself. So I rely on my operation and inverse operation tables. I look at the story of what happened to x, and I see that I immediately times 2 and minus 5. And from there, I hit my absolute value. Much like a parentheses or a radical, whatever's inside the absolute value creates a group. So before coming out of it, I need to make sure that I deal with it. So in my operation chart, I put absolute value. And that tells me I need to deal with it before I do anything else. From there, I do a times 3, and I do a plus 4, and I hit myself with my inverses. I do minus 4, divide by 3, and absolute value is a bit of a unique operation. Absolute values does not have any direct inverse, but there is a way I am able to deal with it to account for my absolute value. So what I have to do is I need to split my equation or my solution into a positive value and negative value. And that's how I deal with my absolute, getting my absolute value, getting my two solutions. From there, I do plus 5 and divide by 2. This is the correct list. Let's see how that manifests. So I'm going to get my t-chart. I do minus 4 minus 4, and I get 3. Absolute value of 2x minus 5 is equal to 15. From there, I divide by 3 and divide by 3. I get absolute value of 2x minus 5 is equal to 5. And here, where the absolute value comes in, I'm actually going to move my work over here just so I have room to do what I need to do. But this is where I'm at in my solution steps. I still need to get x by itself, so I need to get rid of my absolute value, 2 and negative 5. But the way I deal with my absolute value is by splitting my equation. Now, what's inside the absolute value does not change. This is 2x minus 5 and 2x minus 5. I'm going to write it twice. What does change and what I need to account for is I need to account when this solution is positive and when the solution is negative. So I've split myself into two equations where my solutions are both positive and negative, which down the line will ultimately give me two solutions for this problem. So I still have to follow the rest of my steps, but now I have two problems. So the way I get rid of my minus 5 is plus 5 plus 5. This is equal to 2x is equal to 10. I divide by 2, divide by 2. X is equal to 5. So I have one solution, but now I need to look to the other. The way I get rid of minus 5 is by plus 5 plus 5. I have 2x is equal to negative 5 and positive 5 equals 0. And already I could tell I could divide by 2 if I want, but I know that my x value needs to be 0. So my two solutions are x equals 5 and 0. And that's how we deal with an absolute value and how we solve an absolute value problem. The thing I want to remind us, if we do our table correctly, we don't need to remember this rule. But before we jump the gun and see, oh, there's an absolute value, I need to do the split, make sure that you have the absolute value isolated before you do the split. If you do the split at the very first step, it will A, make your life harder, and B, needs to be set up in a totally different way that you guys are not prepared to do at this particular moment. So instead, what I highly recommend is that you wait to isolate, get everything else around the absolute value canceled before you do that split. So with that being said, that is all the parts that you need to be aware of, all the operations you need to be aware of to solve for solutions for equations. And the second part of our quiz is going to be solving systems of equations. So rather than solving one equation at a time, now you're going to be solving multiple equations at a time. Specifically, you're going to be solving using two equations to find the solution for x. And there are two very important considerations you need to know. We saw in our notes that graphically, what happens is that when we have two equations, they create two lines. And the solution for those lines happens when they intersect, when they cross each other on the coordinate plane. So graphically, the solution happens when they both intersect the same point. And we can use that to remind ourselves what the solution looks like or how we start the solution, what we're going to be looking for in solving the system of equations. And that is, since graphically the the solution is where the two lines intersect at the same point, we need to understand that algebraically what that means is that the solution for a system equation happens only when my two equations are equal to one another. That means that we need to set them our two equations equal to one another like so. So I have 2x plus 1 represented and negative x plus 4 represented, and they are set equal to each other because that's how the only place and the only way I could find the solution for both of these equations at the same time. So this is our very important setup. Now, unlike some of our other sections, I can't give you a step-by-step guide how to solve each one of these problems because each one of these problems is so different from one another. So, once you have the setup, the main thing that you want to remember is that we're still doing solutions. We're still solving for x. So our answer needs to look like x equals some value. You're trying to get x by itself, just like we were doing before. The difference is, rather than having one x, we now have two x values. We have an x value on the one side and an x value on the other, which is going to make our lives a little bit difficult, but it does give us a guiding light. It gives us a goal. I cannot solve for x while there are two x's in the equation. So that means I either need to combine or cancel all my x values until I only have one x value left. So you could choose to work with either side, but I'm going to work with my smaller x. I have a 2x and a negative x. Generally speaking, it's easier to work with our smaller x and try and cancel that out first. So I look at my negative x and I recognize, hey, if that's a negative x, the way to cancel that is with a positive x. So negative x and positive x cancel. So I've done the job of canceling my x, but I must still follow the rules of math, meaning what I do to one side of the equation, I must do to the other. So we are using our cancellation rules, and our ability to cancel is now going to be a tool for moving one x value from one side of the equation to the other so that we could then combine them. Because 2x plus x gives me 3x. And of course, everything else gets brought down. So I have plus 1 is equal to 4. So I have 3x plus 1 is equal to 4. And now I only have 1x by itself. And now it becomes just like the problems we were doing before. I want to get x by itself. So I have to get rid of this 1. I minus 1. I have 3x is equal to 3. I divide by 3. I divide by 3. And I have x is equal to 1. Okay, so that's the setup and that's the goal. When you do these kind of problems, those are the main two components that they need you to remember. That the solution only happens when the equations are equal to each other and you must solve for x. And the way to do that is by canceling and combining all your x values until you only have one left. We've got some practice throughout class about how to do these problems. For the quiz, I need you guys to focus up until problem number 8. Problem number 9 gets into using uh, systems equations and factoring. This will be on the test. 9, 10, 11, 12 will be on the test. For our quiz, I just need to make sure that you're comfortable up until number 8. Okay? Now, with that being said, there is one type of problem that I also want to go over. And I think number 4 is a good example of that. So my setup's the same. I want to make sure my two equations are equal to each other. So this is 25 over x is equal to x. One equation is now equal to the other. But I have an x in my denominator. And we haven't seen that kind of problem before this week. But because we know our rules about fractions, we are very equipped to deal with this. So fraction means division. So essentially right now I have 25 divided by x. But I want to get rid of this x. This x is a problem down here. And I know that the opposite of division is multiplication. So I know if I multiply by x times x and divide by x are opposite operations. So those are going to cancel. And of course, because of the rules of math, what I do to one side, I must do to the other. So this is equal to, because this canceled, I have 25 is what's left over, so that comes down. is equal to x times x gives me x squared. So that's the main trick. That is the way that I cancel denominators. It's just by multiplying by itself, but you must multiply it by both sides of the equation so that you keep following the rules of math. And I will let you go ahead and solve that one. Uh, Please make sense of these. If you have questions over the weekend, please email me. I can't promise to get to each one of them, but I will try to answer as many as I can in my free time. So, happy studying, good luck, and we will get to our quiz first thing Monday and or Tuesday at the beginning of class. Thank you and happy studying.